Hey there, so today we will talk about typecasting, and in order to do so, let us add a new class. First of all, I will highlight the src folder, right click, navigate to new and select the class option. Moving forward, we will give the name of the class as hello, and we will also check mark this checkbox public static void main. Alright, so this seems to be good enough, and in here is a warning: the use of default package is discouraged. So we will give the name of a package, and the name of the package could be like org.studyeasy. Now friends, what is package and how to work with package is something which we will discuss in the later videos. Alright, so moving forward, let us click on finish, and here is our auto generated code. Now what is typecasting? Typecasting means conversion from one data type to another. For example, if I type in short x equals 5, then the variable x is of short type, right? And then, for example, if I say int y equals x, then in here there is no issue and Java is not complaining for anything. Let me show you the output as well. So if we try to print y, the output would be 5 and there is no issue. This is known as implicit typecasting, where typecasting is done automatically, where short data type has been converted into a int data type. But if we do this vice versa, for example, we have this short x equals to 5, which is okay, and then we also have, for example, y equals to 10. So this is good, and then we will do one thing: we will type in short x equals to 5 in next line, and we will try to initialize this x variable with a int entity. So let me initialize this with y, and here is an issue. If we hover upon this issue, then it says type mismatched, cannot convert from int to short. So here is the issue. Let me execute this, and there would be a compile time error. And the issue is pretty simple. In this case, the implicit typecast is not possible. Now let me show you this document. Now there are two types of typecasting. First one is implicit typecasting, or in other words, the automatic typecasting. The second one is explicit typecasting. Now when Java will automatically typecast things, first requirement is that the data type should be compatible. For example, byte, short, and long. All four of these data types store integer type of entities. In this case, all four of these data types are compatible data type. Likewise, float and double are again compatible data type, because both of these variables will store a floating point entity. Alright, so moving forward, when the implicit typecasting would be done, whenever the situation is the widening situation, then the automatic typecasting would be done. For example, if we are trying to store a byte type of entity in a short type of variable, then definitely 8-bit of information could be easily stored in a 16-bit of memory, then automatic typecasting would be done. Likewise, if we would like to store information from a short type of variable into a int type of variable, again a implicit typecasting would be done. Likewise, if we would like to store information from a float type of variable into a double type of variable, then definitely double is capable of storing a float type of information. As a result, we can store float variables information in a double variable, right? But the opposite is not possible. For example, if we try to store a 64-bit information in a float variable, definitely float doesn't have that much of space to store such a huge variable, right? So implicit typecasting won't be allowed. In those cases, we can do explicit typecasting. In here, for example, explicit typecasting would be done in situation where, for example, we are storing a double information in a float variable, or we are storing a long information in a int, short, or byte variable. Now, whenever there is a narrowing situation, then explicit typecasting would be done. So here is the overall scenario of implicit typecasting and explicit typecasting. Now let us quickly navigate to Eclipse once again, and let me show you this program. So in here we are trying to store information which is there in a int entity, but we know that a short variable can easily store variable 10, so we can explicitly typecast the information, and the way is pretty simple. So in between pair of parentheses we will make use of the data type we would like to cast to. So we would like to cast the variable y to short, so we will type in short in here, and then everything will work properly. Let me print the value of x in here, and the output is 10. All right, so let me undo the changes and then try to execute this program. Definitely a compile time error, right? All right, so now for example we can also cast this to byte. Again, this should work because we are casting to byte, and byte is narrow than short. It requires less memory than short. Then definitely the implicit typecasting would be done, and the output is perfect. Alright, so likewise we can also check with float and double. So in here I will type in float v1 equals to 10.0 and dub double v2 equals to 20.0, right? So these two statements are perfect, there is no issue, and we need to add f in here in order to get rid of the what we say error. Now this seems to be good enough. Let me type in sysout and try to print v2, and if we execute this, definitely the output is perfect. Now for example we initialize v2 with v1, then again the output would be proper, no issue in here, right? But if we do this vice versa, let me initialize double with 20.0d, and then we will try to store the information in our float variable, then definitely there would be a issue. Oops, in here it needs to be v2. All right, so now there is a issue, right? There is a issue. All right, so this is a very good example to show you that how explicit typecasting is done. Now this is a very good example where we can get a compile time error. Now moving forward, let us do the explicit typecasting. In here we will simply type in float. So Java will explicitly typecast this v2, and then we will get a proper result. Now here is a catch. Now for example what we do, we say 20.111111 and couple of times we do 1. So in total if we count, these are more than 8 times 1. Alright, now let me do some changes in here, and I will type in 20.0123456789. Alright, and I will give the notation D in here. So now this is a double entity, and then we are explicitly casting it. Now in here there would be a loss of precision. Now when we would be converting a double entity to a float entity, now Java will truncate some information from the value inside v2. Let me show you the output. Here is the output. Now this information which is highlighted right now is truncated by Java because we have explicitly typecasted. Now same is the case with this particular notation. For example, if I say int y equals to 65,000, 65,000, and then I say short x equals to y, then definitely there is a issue. Let me do one thing. In here I will say short. All right, Now definitely short is not capable of storing such a huge number, then there would be a loss of precision and we get weird results. And this is the reason why implicit typecasting is done by Java, where there is no ambiguity, and whenever there is an ambiguity, then user need to explicitly typecast and Java will truncate and lose some information if required. Alright, so this is good enough. Let me get rid of this example. These were very basic example. In fact, in here, let me do one more thing. For example, I say string x equals 10, and then I say int y equals x. Then definitely there would be an issue, and try to cast string to int. Then what would be the output? There would be a compile time error, and the issue is pretty simple. We won't be able to typecast from string to int. These data type are not compatible for explicit typecasting as well. Now if we say float x equals to 10.0, then what would be the outcome? Then we would be able to get a proper result. Let me show you the output. Let me print y, and the output would be 10. Now here is the catch. We can typecast from int to float or float to int, which is possible only if we are explicitly typecasting. Otherwise, implicit typecasting between integer type of data to float type of data or vice versa is not possible. Let me show you the vice versa situation as well. First of all, let me declare a int entity. Let us get rid of this first of all. In here I say int x equals 10, and then I say float y equals x. Oops, y equals x. Then the output is proper. Now here let me show you some interesting things again. Let me type in int I equals 10 maybe, and then I will type in float f equals I, and that's perfectly alright. Even though I stores a int information, float is capable of storing int information. But when we will try to print the information which is there inside f, the output would be little different. Let me show you. It would be 10.0. Now the implicit typecasting between int to floating point number is possible. Let me make some further changes. Let me do it like this: long I equals 10L, and then try to execute this program. Again, this works because the range of float is larger than integer type of data types like int or long, and the implicit typecasting is possible from int type to float type, because definitely we can add 0.0 to the specific integer value, but the vice versa is not possible. Let me do some changes in here. First of all, I will type in float f equals 10.0, and then I will say long L equals f. And here is the issue. Java will start complaining for this statement, and there would be a compile time error unless and until we explicitly cast floating point number to a integer type of number. So in here, for example, I cast it to a long type of number, then there won't be any issue, and the output is 10.0, which is perfect. But the opposite of this scenario is not possible. We won't be able to implicitly cast from float to a integer type of a variable. Let me show you the scenario. First of all, let me add in a float variable, and we will give the value of this float variable as 10.0. So this seems to be good enough, and then we will add in a int entity. Let me add a long variable, in fact, long L equals f. and here is a issue. Let me try to show you the output as well. If we try to print L, then definitely there would be a compile time error. Here is the exception. And the way of fixing this issue is pretty simple. We need to simply cast the floating point number to int. So let us cast this, and definitely the output would be 10. Now here is a catch. Again, there would be a loss of precision. For example, the floating point number is 10.532. Then what would be the output? Definitely the information after the decimal point would be lost and the final value would be 10. So here are a couple of scenarios how the typecasting is done, what is implicit typecasting, what is explicit typecasting. And if there is any confusion, try to code some programs, try to cast some variable to some other variable, and also try to research on internet more about typecasting. Typecasting is important, and usually programmers try to avoid typecasting, and usually the implicit typecasting is preferred over explicit typecasting because of loss of information due to the explicit typecasting. I hope you enjoyed this video. I will catch you in the next video with a new explanation.